Today I've got a video for you guys, and what this is I did a 3D model of SV Seeker here. That's what you can see in the video here. I'm panning and zooming around on this. You can see this thing. Did a full mock-up with a hole from dimensions that Doug gave me. This thing is not super accurate, but the parts that matter, which is this edge along the bottom of the keel down here, the trailer is going to have to sit on, that's the important part. That's fairly accurate. He got good dimensions off of that. So that's what we're going to roll with. That's what we're using for the purposes of this video. So what I want to get into here, as you can see we have right now just the hull sitting on the ground. This is the way you see it in Doug's driveway. I'll kind of zoom in, you can see. Now there is some space underneath this thing because I've already got this thing elevated off the ground there. So you can see underneath it that there is a little bit of room there because we're going to need some clearance to get this thing to go down the road. And so what we're concerned with on this is having enough clearance to get down the road and being able to build a chassis underneath it that's going to allow it to be moved. And so what we're working on with that is I've got this here. It's just using the same beams that they used on that house move, but in this case here, came up with something a little bit different, which was to take other beams and put them underneath and then bolt them up from the bottom. And what this does is it gets the beams low enough that they can go underneath the frame, and then the boat can sit directly down on top of it. And then you just have these pieces of wood blocking cut out to allow the boat to sit down on those. That transfers the load to the trailer. Works pretty good. I think this is about the most feasible way that there's going to be to get this thing to water. Something I do have to interject here with is, Doug, on your design you had put the wheels right off of the keels, and the problem with doing that is when you want to start to make a corner and you want to swing, what's going to happen is the truck will start to go this way, and then the back end of the boat is going to want to swing out. It puts the pivot point at the center, and you don't want the pivot point at the center. If the pivot point's at the center, what's going to happen is the back end of the boat's going to be knocking down power poles and things like that, and it really creates a problem. You want to have those wheels further back, not only for that reason, but the other problem you have is back here at the keel. Now I will get back here. We'll turn the dimensions onto this. Dimensions layer, here we go. And so this is only about 2 7/8 inches underneath this keel on the back here, or excuse me, underneath the skeg on the rudder. And so the problem with that is as you're going down the road, this setup, the way we've got it set up, is very, very long. And you have a lot of space under here, so when the front end of this trailer starts to go up, that means that keel's going to drop and it's going to drag on the ground. And I know that thing's been built fairly strong, but the thing we're more concerned with is that if this thing starts to drag on the ground, it could shift everything inside the trailer, so everything's going to have to be chained down really well. Everything's going to have to be really put in there where you need it. I mean, you don't want to take a chance at having that stuff come loose. And so that's something you really have to consider when doing this, is you don't want to be dragging that skeg on the ground there. Or the keels for that matter, if you set the keels down, which the way we set these up, I mean, there's a full 6 inches. Let's go back to the front of the boat here. Now at the front of the boat, the thing we have to worry about is this, is we're worried about being really high at the front of the boat here. And let's go back to the front of the boat here. What we're worried about at the front of the boat is we're going to be very high. We're going to have to worry about clipping things like power lines and whatnot. And so I went ahead, I dropped the dimension in there, and that dimension there comes out to 15 foot 9 1/4 to the top of that right there. So if we're 6 inches under the keels, that's not too bad. That's a doable move. The thing I'm really concerned about, more so, is just the skeg on the back there. So it may be worth the while to pitch the whole boat forward a little bit when building the cradling underneath it. And so it won't sit level underneath the keels, which is actually going to give those a little bit of clearance anyways, because if the front of them are still at 6 inches and you bring the back up to where they're at 8 or 10, that just helps you just a little bit more, just getting a little more ground clearance under those before those tires have to climb over anything. That might help, I don't know, but I know it will get some more room underneath the skeg on the rudder there, and that's what we really have to be concerned with in this move, because like I said, if that thing drags, it could literally cause the whole thing to shift on the trailer, and then we'd be into a world of hurt trying to jack it up, move it back around, get everything repositioned, and be trying to do this in the middle of the highway. And my concern there is if something like that happened, you're going to have to call a crane out there to do that. I mean, that's something that where it could turn into a really big deal really fast, and it could potentially lead to the boat being confiscated by the state of Oklahoma. And that would be really bad because they would probably just come out, cut it out, and remove it from the roadway that way. And so that would be a very big problem, and we certainly don't want things to end that way. And that's something we need to be very concerned about. I mean, just tilting it up about 2 inches in the front, I think that would give about 6 inches under the keel. I'm not going to take the time to draw it. I just want to show you guys this, show you what we've got here. I mean, this is a pretty cool setup, I think. I think it has the potential to get this job done, get it done as simply as possible, because all we're talking about here is pieces of beam. Now, these pieces of beam are configured in either 4-foot or 8-foot dimensions. These ones here at the front are 8 feet apart, and so what that's doing is that's spreading the load of the boat between the frames inside of the boat, so you can directly match where the load is being placed onto the trailer between the frames and the boat, so it carries the load all the way through, and so you're not going to wind up denting the hull. I mean, the hull's pretty strong as it is. You just want to be absolutely sure. And then the same thing back here. Obviously, you got the wheels in the way here, and these are just the standard dollies that the house moving company already has. They'll be able to bring that set of dollies, throw them underneath this, drive it right on down the road. So I don't see any issue with doing that. Again, we're using the wood blocking on the back here to hold everything up. This is just a piece 1.5-inch plate on either side, 2-inch diameter bolt going through. These bolts are going to have to be very strong. It's more than just the load that they're supporting, because there's a twisting force that's going to be applied to all these. And so those bolts need to be like way, way, way crazy oversized, because you're talking about levers, and those levers, with the types of weights that are applied to them, can stretch those things and pop them right apart. So, I mean, probably a 2-inch bolt is what's going to be necessary here as I've drawn. I think doing that, I think it'll be safe. Other than that, I think this is pretty much what it's going to take to get that boat to water. I don't see a whole lot of other options. I did look at possibly putting a stretch trailer underneath the trailer, because when you stretch it out, that section of the trailer is narrower. The problem is, though, is that you just wind up being so long when you do that. I don't think that's a viable option. A rail trailer would potentially work, but the problem is, again, you're running into the space underneath the keel, or excuse me, underneath the keel spine. I mean, it's not really the keels. I mean, I'm calling it the keel, the center line of the boat. And so when I say that, it's the space underneath the keel there before the skeg. That's where you're going to have a lot of a problem there. So I really think this is probably the best outcome that we could have. It's going to be by far the simplest to put together. I mean, this is very simple. The one thing that I do worry about, and this is different from a house move, because a house move doesn't have anything dragging down close to the ground. What I worry about is on the front, having this be a rigid lockup. I looked at the unit that he's got for moving the houses, and I would be a little bit hesitant to try and pull the boat with that. I would want to build something that's a little bit more stout than that, and I would want to see it have some type of hydraulic mechanism in it to actually lift the front of the boat up and down. And the reason being is, if you have the ability to lift and lower that, you can actually change the pitch. Like, let's say you have something you have to go underneath with the front of the boat, and you can drop it down, poke that part underneath, and then bring it back up to bring the back end through, whatever it is that has to be done. Because the thing that really concerns me, and this is just from my experience in hauling heavy equipment, is that you're going to have issues with the bottom dragging, you're going to have issues with the back dragging, because the roads over there in that area are very unlevel. I mean, even just leaving the driveway there, you know, you've got the curbs to contend with and everything. We're going to be putting boards down there like that to get the thing to climb over the curb and do it properly. It's going to be a lot of work to get this done. I mean, you'll be putting, you know, oak blocks down, and then you'll be putting, you know, steel plates on top of that to roll over the whole time we're moving this thing to get over a lot of those types of obstacles. And so it's going to be a fairly complex move for that, but there's nothing about this that makes me think that it's not doable. I think that this being done this way, I think it would be fine. I have hauled pieces similar in size to this before. I'll throw a couple of pictures in here if I can find them. Have hauled a lot of large units like this. So I mean, this isn't craziness. I mean, we're not even 16 feet high according to the dimensions I have here. That's assuming that everything's right. Now I don't know if the dimensions I have, if it's to the top of the bulwarks or not, but we'll just have to see on that. Anyways, guys, just want to throw this video up here, get this put together this morning for you. That's what we've got. If you have any suggestions, leave them in the comments below.